In today's lesson, we're going to look at the standard deviation, which is another measure of spread or dispersion. So what it's measuring is how far away on average is our data from the mean. How spread out from that one value is it? So if I want to know how far away a data value is from the mean, we would find the difference between the two, yes? So x minus mu would give me the difference between x, the data value, and the mean, mu. Data values that would be greater than the mean would have a positive difference. Data values less than the mean would have a negative difference. So if we were to add all these up, remember sigma means add up a bunch of stuff, and then divide by how many things there are, that average would not be accurate because some of these differences are positive and some are negative. What we're going to do to take care of that is if we square these differences, now we have a positive number. So we're going to be adding up a whole bunch of positives, but since we square, we also have to square root, like that. So our standard deviation, sigma, is given by this formula. The sum of the differences squared divided by n, and then square rooted. So standard deviation is the square root of this thing called the variance. Sigma squared is what we call variance. You very rarely use variance. Most of the time we talk about standard deviation. For a frequency table, standard deviation is found similarly, but we're going to be multiplying the differences by the frequency because each difference gets used like 5 times or 8 times or twice. And then we divide by n, or another way that we give this is the sum of the frequencies. The sum of all the frequencies is n. It's the number of objects in our data set. When we do this, the population parameter is sigma for this. The sample statistic is S. So S is the abbreviation we use for standard deviation of a sample. We're going to treat all of the standard deviations, all of the data sets that we're going to use as populations, and to simplify things, we're just going to stick with sigma. So here we have a list of data, and we have 30 farmers, so we have 30 data values. How many farm workers do you hire during the season? And one farmer hires 4, the other one hires 5, some hire none, some hire 9. We're going to calculate the standard deviation by hand, and then we're going to go ahead and calculate the standard deviation using our graphing calculator. We could simply do all of this, have one whole column for the x values, and then find the differences, square them, and work that way. But we're going to do this with a frequency table to make our lives a little bit easier. So one person said they hire 0. One person said they hire 1. 2 people said they hire 2 people. 6 people said they hire 4 people. So what's the sum of these frequencies going to be, guys? The sum of the frequencies, 30. Number of farmers that were polled. So what we want to do here, we're going to need to find the mean. The mean is going to be the sum of the frequencies times x divided by the sum of the frequencies. So we're going to take each of the f's and multiply by the x's. 1 times 0 is 0. 1 times 1 is 1. And we're going to want to add up all of these numbers. That's what the sigma f times x is. So add up all of those numbers that we multiplied, we get 150. So our mean is going to be 150 divided by 30. So our mean is 5. The average number of workers that will be hired is 5. So now we can start to calculate the standard deviation by hand. So we found the mean. Now we're going to subtract the mean from each observation. That's this column, x minus mu. So we're going to do x, 0, minus 5. So what's going to go in this first spot is negative 5. And then the next x value is 1, so this is going to be negative 4, and so on and so on. And you notice some of these are positive, some of these are negative. If we added these up, this 4 would cancel with that one. They'd become 0. 3 and negative 3 become 0. And we wouldn't get an accurate measure of the spread because some stuff is higher than the mean, some stuff is lower than the mean. So now this is where we square each result from step 2. So now these numbers are positive. Now we're going to multiply by the frequency. And we're going to add that up. So our formula for standard deviation is square root sum of f times x minus mu squared divided by n, or sum of the frequencies. So what I have now is this 152 as my numerator. My denominator is going to be 30. So our standard deviation, if we take the calculator, 152 divided by 30, put a decimal point after it to approximate, and then we square root that. This is not the standard deviation, remember. This would be what we call the variance. So 2.25. Now you're going to hear me say this a lot during this course. For IB, all decimals must be given and approximated to 3 significant digits, no more, no less. So if you're going to approximate an answer, you should be giving 3 significant digits. Okay, so we did this by hand now. We got 2.25 as our standard deviation. We've got 5 as the mean. So what this means is, on average, a farmer will hire 5 workers, and the data that we collected is on average spread out by, it differs from the mean by 2.25. Let's use the graphing calculator now to do this same calculation. So what we're going to do is we're going to add a page to our calculator. I'm in the document side of this. I'm going to add lists and spreadsheets. And we're going to type in the name for this. Let's call this workers. And we type them in. And when you reach the end, make sure that the length of your list agrees with how many data values you have, because the easiest and most common way to make mistakes here is by having the wrong amount of data in your list, forgetting one or adding an extra data value. So I have 30 items. I'm good to go. So I'm going to go into Menu, Statistics. We're going to go to our friend One Variable Statistics again. One list. My X list is in column A. It's my workers. I'm not going to do anything with the frequency list because I type this in not as a frequency table, like down here, but as the entire list. I could have done a frequency table also. I'm going to put my results into column B. I press OK. And if we scroll up here, there's that standard deviation. We use sigma, 2.25. It's the same thing I got doing it by hand. Our mean was 5. There we have it. So the last thing to look at, this is something that I want you to do and investigate. What happens if we add or multiply the data set by something? When we add 10 to all the data values or add 100 to all the data values, the same thing will always happen to the mean, and the same sort of thing will always happen to the standard deviation. What I want you to do is figure out what those things are. And similarly, what happens if we double all the data values? What happens to the mean? What happens to the standard deviation? So I want you to finish this section up by doing this investigation, and then go talk to your teacher and make sure that you're talking about this and understanding what differences happen as you add and multiply to your data set.